Welcome back to the end of the 8.3 notes, AP Statistics. If you wanted to know what the answer was to that last question in the previous video, your confidence should, or your critical value should have been 2.898. So hopefully you got that right. Using the calculator, this is our review. Just finding basic probabilities, basic sampling distribution, we already know how to do. If we've got a normal, okay, so if we have something normal, you can find the area under the normal curve. You already know that, the normal CDF. However, now if we have t-distributions, this is called the t-CDF, where you put in the upper and the lower bound and then just the degrees of freedom, and it will do all the calculations for you. Chances are you probably won't need to use that one very often, but if you ever did, there you go. So I'm not going to go over that with you. Also this next one. If you needed to find critical values, you could also use inverse norm on your calculator, which we've talked about before, if you have a normal distribution. Now, if you have a t-distribution, you can also use inverse t, where you put in the percentile again, and now you need to add the degrees of freedom to make that adjustment. All right, so for our example here, 0.25 at 6 would give a critical value for 95% confidence at 6 degrees of freedom. Okay, so just something to think about there. I do want to go over using the calculator to find confidence intervals. You definitely need to know how to use that, because it definitely speeds up your time. The one thing I want to stress, though, is you cannot use the calculator unless you state on your paper, in your planning section, after you've done all of your checks, that you are now proceeding or met the conditions for either a 1 proportion z interval or a 1 sample or 1 mean t interval. And we'll get into that with our first example here. But let's go ahead and go to the calculator and see what the results look like. So if you're using the scratch pad, you can do it from the scratch pad. If you're going to do it from a new document, you can press menu and just open a calculator page. And then what's going to happen here is we want to go ahead and go to menu like we always do. So then we go to probability. Oh no, I'm sorry, I'm not reading my own directions. We go to statistics, and there they are, the confidence intervals. We've so far seen the 1 proportion z interval. There it is. And this is what you use with 1 proportion z intervals. Pretty straightforward. And it's very easy to use. So it's your number of successes. So in the example I gave, I said number of successes was 8, number of trials was 40, and I did give a confidence level of 0.95. Okay, so let's see what we end up with here. So you can see right here, there's our lower bound of our interval. So if we were going to write this, let me say, nope, it doesn't let me write on here. But if we were to write it out, I'd write 0.076, comma, 0.323, or actually round that up to 324. It even gives you your p-hat. It calculates that for you. It gives you your margin of error, so you wouldn't have to actually calculate that, although it's not hard to do. And that just reminds you how big your sample size was. All right, let's go ahead and move on to those t intervals. Do the same thing. So we're going to go to statistics. We're going to go to confidence intervals. And this time it's right there. Okay, so the question might become, well, wait a minute, what's that z interval for if we didn't use it for proportions? We'll talk about that in class. I'd rather you guys understand that in class. For right now, to be safe, always just use the t interval. It just makes your life simpler. Okay, so the data input method, if you happen to have a list of values, like a list of your data saved in a list in a data statistics page, then you would select that and you would just name whatever you named that list. But we are dealing with statistics in this example. Okay, X bar in our example on our notes here, it's 7.2. And then, oops, if I push tab, there we go. And then let's see, the next one is, I've lost my place, 3.1 is our standard error. Notice it's a capital letter. Tab to get to the next one. Our sample size was 30. And our confidence level, once again, was 95%. So push enter a couple times, and there we go. So now look at what you get this time. Same thing, we still get our lower bound and our upper bound for our confidence interval. There's our mean again, our margin of error, but now you see the degrees of freedom, which is 29. It also gives you your standard error, which is 3.1. So that's rather nice of them that they give that to us. And then we've got 30. Okay, so all the data is given back to us. All right, so on the next page, let's look at where we're going with that. Let's take a look at what new conditions need to be met for determining if we can proceed with the procedure for a one sample t interval for the mean. When the conditions are met, we've got to do randomization and 10% rule. Those two will always be standard. Those are the two you always check. The next one is normal or large sample. I need to fix these notes because I really shouldn't talk about normal anymore because they're really not normal. It says if the population has a normal distribution. This is actually inaccurate. It says use Z as the critical value. You can actually still want to use that T distribution even if your population is normal. We saw that in the simulation that I did earlier. I apologize. I really thought I had taken that off your notes. So cross that out. The sample size is at least 30. Okay, that's the central limit theorem. But more than likely, your sample data is going to appear roughly normal. All right, let's take a look at the new conditions that need to be met for a one sample t interval for the mean. Our conditions, first two, always the same. Randomization, you got to check either it says it is or you can reasonably assume that it is. 10% rule is independence. Remember, that's also the rule that allows us to go ahead and calculate our standard error. Normal, large sample, it has to meet one of these three. The population has a normal distribution, and I want you guys to cross this out. I thought I had fixed my notes, but apparently I forgot to hit save, and I didn't actually save this part. I wanted this crossed out. Okay, so that needs to go. You cannot use the Z if you've got a normal distribution. We saw that in our simulation that was in the previous video. It still goes all wonky and you need the T distribution. If your sample size is at least 30, you're good to go. However, if the sample data appears roughly normal, symmetric, and nearly normal, you must have a graph to prove this. So you're going to see an example of that. I've been talking about it, but we've never seen one. This is the first time we'll see it. The formula for calculating our confidence interval, so we'll call that the CI, is equal to your statistic, X bar, plus or minus. Now we're going to call this T star, so your critical value from the T table, times the standard deviation of X bar, so the standard deviation from your sample, divided by the square root of n. Let's break down what some of those parts are. The margin of error is the part from the T star times the standard error, or sorry, no, that's not the standard error, the standard deviation divided by the square root of n. Okay. And then the standard error is equal to this part, the standard deviation of x bar divided by the square root of n. So don't forget that critical value T star, sometimes they'll call it, I like to get a little lazy, I apologize, n minus 1, so that shows the degrees of freedom. So another way to write that is that this is your degrees of freedom. So just remember that you get from the sample size. Moving on to your first example. So we're still going to follow our 4 steps. State, we want to estimate mu at the C% confidence level. Don't forget to define or use context for what mu is. Check your conditions, and don't forget to state the procedure. Use the formula to calculate the interval, and then we are C% confident that the interval from captures the true mean, blah, blah, blah. Okay. I'm going to have you guys go ahead and read through this one. It's a lot to read. I'll let you do it at your leisure. But what it comes down to is that there were, I think it says somewhere in there, a bunch of cars, I don't even know how many, that were observed, and the data is graphed here. It's graphed because the sample size was less than 30. And we can see from the graph that and it never says that it's from a normal population. All right, so then it says construct a 90% confidence interval for the mean speed of all vehicles traveling on this road. So state, we want to estimate, I'll let you read through that. Randomization, 10%, good. Nearly normal. So histogram, here's the histogram, is pretty unimodal and sort of symmetric, so we go ahead and proceed, and it looks like our degrees of freedom is 22. Oh, there were 23 cars in that sample. Make sure you define all of your data, so right here, okay, and then put it into the formula. So make sure you do all those calculations and all that fun stuff. All right, and then we conclude 90% confident interval. You can read the rest of that. All right, thank you for hanging in there with me. I know this was a long one. I may ask you a couple questions about this just to make sure you got some of the key points, but let me know if you have any other questions.